And you know, as far as grading goes, I don't curve. I don't do any kind of curving stuff. So you are not competing with your neighbors. You are working together. I want you guys to learn and not feel like you're competing. And then yeah. Anyway, okay. And then and thank you guys for who've put questions up on Piazza and those who've answered. I've seen a lot of good answers up there. There's when I do want to say something about Piazza, and when you do. Oh wait. Okay. Hang on. Mine has the teacher view, so I shouldn't show you that. But basically, when a student posts an answer, other students can also edit that answer. So just because somebody has written something in the student answer section doesn't mean you can't then go in and add additional stuff, and you can edit it. It's kind of like a little bit of a wiki in that you can edit the student answers and kind of collaboratively come up with a good answer. So yes, you can put additional comments in the follow-up section, but I would just say if you have something to contribute to the answer towards that question, just go ahead and put it in the student answer. Don't feel like just because one student wrote an answer, you can't go in and change it, okay? Even if I've endorsed that answer, you can go in and add, you know, your comments and ideas, okay? And feel free to continue to post questions. My only request is that you don't post direct code. If you're going to write any kind of code in your answer, keep it as pseudocode. So something that kind of conveys the general idea of what's happening in code, but not something where you can copy and paste it into R and it will start to run. Okay, that's my only request with that. Okay, I will post homework 2 soon. Homework 1 is going to be due very soon, and so homework 2 will make its way, and today we will discuss subsetting. And so let's take a look at that. Okay, so we've already talked about subsetting a little bit last week, and the idea of subsetting is you've got a large object and you need to just pull out certain pieces and components out of it. We talked about subsetting a vector, an atomic vector. And because an atomic vector is a one-dimensional structure, you can just provide it kind of the index, or if it's named, you can provide it names to subset what you want. Here we'll talk about subsetting matrices and arrays, and then we'll talk about subsetting data frames and things of structures that are two-dimensional or more than two-dimensional. Okay, probably the most common way is subsetting with multiple vectors. This is probably the way you are familiar in subsetting a matrix, but that you can subset other ways as well. So for example, we will say we're going to create a matrix with the values 1 through 9. We didn't actually print this out here, but you can imagine a 3 by 3 matrix, 3 rows, 3 columns, with the values 1 through 9 going down columns. And here we're going to name the columns A, B, and C. And if I say I just want to subset matrix A, and here I'm doing 1 colon 2, which means I want rows 1 and 2, and I leave the spot after the comma blank, and that will return all the commas. Okay, so we saw this back on Friday when we said if you subset with the square brackets and you don't put anything in there, it's going to return the entire vector. And the same idea holds here. If we don't put anything in there, it's going to return all the columns. So that before the comma tells you which rows you want, after the comma tells you which columns you want. And so here it says I want the first 2 rows and all of the columns, and that's what we get. Here I can say the rows that I want the first row true, the second row false, and the third row true. So this will return the first and third rows. And then as far as columns that I want I just want column B and then column A, and that's what we get. We get column B and column A, and we can see it is the first and third rows. Likewise, we can also provide negative values and things like that in the same way it worked for atomic vectors. If I say -2 as far as the columns, it will return back everything but column 2. If I put in a 0 here, it will return none of the rows. So here I get back basically nothing, a matrix with 0 rows and 2 columns, columns A and C. Okay. There were questions on Piazza about, what is logical 0 or character 0. Those are indeed vectors that are of 0 length. So if you have a character 0 vector and you combine a character 0 vector with the value 3, what would happen? It would coerce the 3 into a character and return a character vector of now length 1 with just, quote, 3 inside of it. Okay? So it's basically a container telling you what kind of data is to be expected, but there's no values inside. Okay, so anyway, here we have a matrix with 0 rows. One thing to note is that when you subset a matrix, it will simplify the result here, okay? So when you ask, is the matrix A, is it a vector? It's going to say false, right? It's atomic, but it's not a vector because it's got dimensions, 3 by 3. If I say I want to subset A, I just want the first row, give me all the columns, so I write 1 comma, it returns back the first row, and it simplifies this to a vector. And we can say, is it a vector? Is A bracket 1 comma, is it a vector? That's true. So rather than returning you a matrix with 1 row and 3 columns, it has simplified that to just a single vector with 3 elements in it. And thus, the behavior of this is a little bit different from a matrix. So certain things may be expected or unexpected. Okay. There is a way, if you want to preserve the matrix structure, if you want it to return a matrix with 1 row and 3 columns and preserve that, there's a way to do that, and we'll discuss that later. Okay. This, again, a matrix, you can also think of it as an atomic vector where we give it dimension properties. And so here I've created a matrix, a character matrix, okay? And here I've just used the outer function, which I don't know if you guys are familiar with the outer function, but it takes in 2 vectors, and it kind of sets each vector basically along each axis, a vertical axis and a horizontal axis, and then applies a function for every single possible combination of those things, okay? So when you do 1 through 5 over here and 1 through 5 across the columns, the function paste then says, give me every single combination, and you're going to get 25 things here. So your paste is just stick the characters together, okay? And so because of this, I can ask for, this is a matrix, and I could subset it using kind of 2 vectors in the same way like this, or I can provide it just a single vector. So notice here, I am not providing, there's no comma inside the square brackets. I am just providing it a single vector that says I want the 4th and I want the 15th element, okay? And so this will return back 4 comma 1, okay? This is the 4th element, and then it counts by column. So this is the 5th, going down the 2nd column, we're at the 10th, and going down the 3rd column, this is the 15th element. So the fourth element is 4, 1. The 15th element is 5, 3. Okay. And so you could request specific values from this matrix by pretending this is just treating it as if it were a single atomic vector of length 25, where it counts down the columns, counts column-wise. Does that make sense? So here I'm now subsetting without the use of commas, because a comma would say I want this row, the intersection between this row and this column. Whereas here you're just saying I want the 4th element and the 15th element. Okay. And then the last way is to subset using another matrix where each column refers to a one of the dimensions in the matrix. Okay, so a matrix has 2 dimensions, and basically I'm going to provide it a matrix with 2 columns, and each row is then going to be coordinates of the values that I want. Okay, so here I'm creating a matrix called select, and just so you guys can see what we're doing here. Okay, so select produces a 3 by 2 matrix. So when I subset the matrix vals by select, it's going to return 3 values, and the 3 values it will return will be the ones with these coordinates. It will return the value at kind of coordinates 1, 1, coordinates 3, 1, and coordinate 2, 4. So when I say vals subset based on select, that is exactly what it returns. It returns back 3 values where I selected them using these coordinates. Okay? And so if you have a higher dimensional array, so if you have a 3-dimensional array, the way you would select values is you would have to provide it a matrix with 3 columns, 1 column for each dimension. Okay, so I hope this makes sense. So in terms of selecting values from a matrix, okay, probably the most common way we use is by saying I'm going to provide a vector for the rows that I want and a vector for the columns that I want. Okay. So if you're subsetting a matrix, you're going to provide it 2 vectors, one for the rows you want and one for the columns, and it will return the intersection of those rows and columns. Okay? But the other way is you can treat the vector as if it were just a single atomic vector, and you would say I want just the values at these indices, and then lastly you can provide it a matrix with basically coordinates of the values that you want. So all of those methods work, although probably the first method is the most commonly used one. So here is an array in 3 dimensions, and I'm creating a matrix with 3 columns, and it will return back 2 values, 3 columns, 2 rows, so it will return back 2 values, and the first one will be in row 1, 2nd column, 1st layer, so that's going to be 3. The second one will be row 2, 3rd column, 2nd layer, so row 2, 3rd column, 2nd layer, 12, so it returns back those 2 values. Okay. Does this make sense? Is this good with everybody? Okay. With data frames, we can do we can subset them in the way that we subset lists, and we can subset them in ways similar to matrices, because again, the underlying structure for a data frame is a list, and but it has 2 dimensions to it, so you can subset kind of the way you would subset a matrix. All right. So here we're going to just kind of create this matrix, data frame DF, which has 3 rows and 3 columns. Column X is 1, 2, 3. The column Y is 3, 2, 1, and the column Z is ABC. So this is our data frame. And here I am providing it by saying, I'm giving it a logical vector here. I'm saying df $x equals 2. So if we were to just take a look at that logical vector itself, so if I say df $x, that's going to be 1, 2, 3, and I say equal 2, then it gives me false, true, false. Okay? By putting that in front of the comma, I am basically saying df, I want the vector false, true, false inside here. And so this will just return back the second row. Okay? Df $x equals 2. These two things are exactly the same. Because that's what df $x basically says. I just want the row where x is 2. Okay. You can just also provide a vector. You can say I want the first and third rows. So you say I want C1, 3. Before the comma, it gives you back the first and third rows. Okay. Notice here, I don't have a comma inside the square bracket. So this is subsetting as if it were a list. Okay. So if I just say, so again, df is this, but if I do, here it prints it as, as a list. I've got x, y, and z. And so here I can say I just want x and z, and that will return 1, 2, 3, and ABC. And so I can say df subset where I just get x and z. Okay, so no comma, not to specify which, it's just subsetting the named list. Okay, I could put a comma in front of it, and I would get the exact same thing. This would say I want all the rows and the columns x and z. Okay, so these two things are the same, but because it's a list, I don't have to put the comma in front of it. Okay, I could, and I would get the same result, but at the same time, I could also just take advantage of the list nature of the data frame. Okay. And so if I did df bracket, and I did false, true, false, okay? And I forget to put a comma in here, what will this return? So I'm subsetting the data frame, and I provided a logical vector, false, true, false, but I don't put a comma outside of that.
Error.
Is this going to return an error? What will it do? Yeah.
Would it return the columns that correspond to true?
Yeah, it would just return the second column, okay? So in this case, it's going to return column Y, because what it's doing is it's looking at the internal list structure, and it says, I won't return column X, I will return column Y, I won't return column Z. So it gives me back false, true, false, okay? So this is, so this thing is exactly the same as doing this, not exactly the same, in that when I put in the comma, it simplifies it to a vector, 3, 2, 1, and here it preserves kind of the list structure. Whereas if I put the comma after false, true, false, what will this return? It will return the second row. Okay, so here I did false, true, false with no commas. It returns back the second column, and it preserves it as a data frame. Here I did data frame blank, comma, false, true, false, and it returns back the second column, but I forgot, it simplifies it to a vector. And then here I do false, true, false, comma, and it returns back the second row. Okay, and I believe, is this, I believe it simplifies this. Oh no, it preserves the data frame structure. So when I say false, true, false with the comma, it returns back the second row and it preserves the data frame structure. Okay. Okay, so we did this. Oh, whoops. We did this already. So we did X and Z. If I put the comma in front, it returns back the same. And I guess I did write this in here. There's an important difference if you select a single column. Matrix subsetting simplifies by default, okay, whereas list subsetting does not. So if I do select data frame, just column X, it preserves it as a data frame, whereas if I put the comma X, it returns it as a vector. All right, let's just take a quick look at a few things. What will go wrong if I do this? So empty cars, just so you're familiar with empty cars. So empty cars is a data frame. It's got columns MPG, cylinders, displacement, horsepower. I don't know what this is. Okay, stuff about cars, right? It's from Motor Trends, and it's I think pretty old because I don't think they make some of these cars anymore. Some of these cars have endured the test of time, but this is back when you had cars. Your Honda Civic had 52 horsepower, and people were happy about that. Are there any cars with 52 horsepower today? How much does a smart car have? I think, all right, no, anyway, probably your garbage disposal has more power now. Okay, what will go wrong if we have empty cars $ cylinder equal to 4? Maybe it's too easy. You have a single equal sign, okay? Single equal sign is not a logical test. It's an assignment operator, so it will not work. Here you need the double equal sign to test, and this will return back trues and falses, and it will return, and so when you subset on this, it will return back only the rows where the cylinder is equal to 4. So where cylinder equals 4 is true, equal 4 is true, and it will just return back those rows. Okay. Here I did -1 through 4. Yeah.
You can't have negative next on the row.
Yeah, you can't have negative mixed with positive. If I want to remove the first 4 rows, I would, well, so here I can have positive 1 through 4, or I could do negative. So I didn't put this in the slide, but I could do negative parentheses 1 through 4, and this will return back all the rows except for the first 4. Okay, so here, this will return back the first 4 rows, which I guess is the Mazda and the Datsun and the Hornet. I don't know what well, anyway, okay. So you can't mix negative and positive. If you want to remove the first 4 rows, you'd have to do negative and then put that 1 through 4 in parentheses. Okay. All right, what about this? I've got empty cars, cylinders less than or equal to 5. Yeah.
You're treating it as you're treating out or empty cars as a list.
Yeah, so here I'm missing the comma, right? So I need to say I want the rows where cylinder is less than or equal to 5. Okay, and that would work. Or if I leave this out, where did it go? So I get this error, okay? So if I did empty cars, $cylinder less than or equal to 5, I get something where it says undefined columns selected. What's going on there? Well, I get a true-false vector with I don't know how many values is this? Okay, like 30 values or something. And so it's trying to select the columns that correspond to this. So it's going to say false, I don't want this column. False, I don't want this column. True, I want this column. False, I don't want this column, and so on and so forth. And I think we have, what, 11 columns or something? And so it gets to the 11th column, or the 11th true-false value, and it's okay, but then it gets to the 12th column, and it says, like, you want to select the 12th column, it's going to say you're trying to select columns that don't exist, right? So if I took this and I subset it just to kind of like the first 10 things, then it would actually work. I could do empty cars this. But this is probably not what we wanted, because it's going to just go through here. It's going to say true, 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 and it just says, okay, I will return back the 3rd column and the 8th column and 9th column. Okay, and that's probably not what we wanted it to do, because we're here, when I don't put in the comma, I'm treating it as a list. So if you want to say I want the rows, you got to put the comma in there. Okay, over here I've got empty car cylinder is equal to 4 or 6. Yeah. Yeah, this OR operator is, for logical values, requires it to, you need to give it 2 true-false vectors, okay? So what will happen here, what would happen if I ran this? It would return all the rows, because what's going on is here you get a true-false vector, empty car cylinder equal 4. That will be true-false, and it'll be true only for the ones where cylinder is equal to 4. Okay? Over here I'm giving it a 6, and I'm providing it this logical operator OR. Okay? The logical operator OR will coerce the 6 to true, right? And then it's going to recycle that true. And so we're just going to have a whole bunch of true values. And so now we've got a bunch of true falses or a bunch of trues. And so then that just becomes true for everything. And it's going to return back all the rows, which is probably not what we want. So I'll go ahead and I'll just show you what happens here. And so indeed, it returns back everything, because if we just look at what happens on the inside, so if any time R does something that you didn't expect it to do, you can always just say, all right, well, what is this thing doing? And then we're like, oh, we just get a bunch of trues. That's the problem. So what we want to actually do is we want this where the cylinders are 4 or the cylinders is 6, because now this will only be true for, we've got this is equal to true or false, and this is trues or falses, and then it gives me the OR operator there. Okay, so that's how it goes. If I did empty cars 1 through 20, what's it going to do? It's going to, again, I didn't put a comma in here, and so it's treating it like a list. We only have 11 columns, so it's going to select the first 11, and then it's going to try to select columns 12 through 20, and it's going to say, you can't do that, okay? This is going to return error because it's going to say you're trying to select columns 12 through 20 which do not exist. If I did empty cars 1 through 20, it gives me back undefined columns selected. And we just have to, all we have to do is put in a comma that says I just want actually the rows 1 through 20. Okay, is that good? Subsetting data frames. All right, we've got lists. Okay, lists and data frames are similar, except lists, the different elements in the list can be of different length. And we can subset a list in a similar way for subsetting an atomic vector, all right, if we use the single square bracket, it will always return a list. Okay, so if we have, and let me just create a list here. I'm going to say L is going to be a list of 1 through 5. Okay, so L is a list, oops, actually not what I want, 1, 2, 3, 4, 5. So here I've got, L is a list, there's 5 things in my list, right? And if I say L single bracket 3, it will return back a list with 1 thing in it, the 3. Okay? So subsetting a list with a single square bracket will always return a list. So here I've created a list with A, B, and C, a numeric vector, a logical vector, and a character vector. And then when I say D single bracket 1, it gives me back a list with the values 1, 2, 3 in it. And if I say, here I'm creating another list, L1. L1 is a list of a list, okay? So I've got list 1 through 3, and then 1 through 5. So here it's, the top level is a list of 2, and then inside of that I've got another list of 2. And if I subset L1 to just say, give me back the first item in there, it gives me back a list with a list inside of it. Okay, because all it's doing is it's just going to say, here's the list of 2, but I'm going to return back the first thing, which itself is a list of 2. However, if I use the double square bracket, it returns back what's inside. Okay, so let me just kind of, I'll skip to here and we'll go back. Remember, I described the list as kind of a train, right? And when you use the single square bracket, it gives you back the train, cars. When you use the double square bracket, it gives you what's inside the train car. So here, if we have a list X is a train carrying objects, X double bracket 5 is going to be the object inside the 5th train car. X single bracket 4 through 6 will be the train cars 4, 5, and 6. So you will get back a list. A single bracket will just return the entire train car to you. And so when you use a single bracket on a list, it returns back a list. It returns back the entire train car. If you want what's inside that train car, you've got to use the double square bracket. Okay, and so that's what we have here. This list, you can imagine 2 trains, and inside the first train car is another little train inside of it. Okay, if I use the single square bracket, it gives me back the first train where there's a train inside. If this makes sense, okay? Whereas if I use double square bracket 1, it goes inside that first train car and then it just gives you the train of 2 that's inside. So if we go back, it will give me just what's inside of here, not the container. Okay, so here we see the kind of the structural changes here. So here it says look inside, double square bracket says look inside that first train car. So we've got we've got a train, and then inside the first train car is another train. So here is look inside that first train car and give me back the second car that's inside the thing. So it gives you back a list itself here, okay? Whereas if let me just skip down to this third example, it says look inside the first train car, and then you find another train inside there, and then it says look inside that second train car, then it gives you the actual vector, A, B, C, D. And then you can say, well, I just want the second item inside there, which is B. Whereas if here it's saying, it gives you back and it says, this thing doesn't exist because you're saying, look inside the first thing, right? You find a train in there, and it says, okay, now subset it to the second train car, and you're getting a second train car, and then you're asking for it to subset that, but you can't because you're just getting back one actual train car. So just think of lists as these trains. I don't know if that's a helpful analogy. It's helpful in my brain, so that's why I'm telling it to you guys, but maybe you hate trains and this thing is not useful. Yes, question?
So on the first line there, you're turning a list? Is that correct? Yes.
So because it's the top level structure, maybe I made this example too complex, is it's a list inside a list.
Okay.
Okay?
The first element of the top level.
So the first element of the top level list is itself, inside there is a list of 2.
Okay.
Maybe we should do a different example.
No, that makes sense.
This is okay? Do these things make sense? When every time you're trying to subset lists, it's always helpful to look at the structure. Okay? And so here at the top level, I've got a list of 2. Inside the first object in the list of 2 itself is a list of 2. Okay? And that's why we have all of this, double square bracket nonsense here. Is this okay? So anytime you see these double square brackets being printed, you know that the object being returned is a list. Yes? Go on.
Double brackets is the contents of it.
Yeah, double bracket tells you it is the contents of that list.
Okay.
Yeah. Yes?
Why does the single bracket work if the element is in a list?
The single bracket works if what is in a list?
If the element isn't in a list?
When we're subsetting, what are we trying to subset?
Oh, okay. It's just for.
No, this is for lists. So you can subset a list using single square bracket, and it will return back a list. If you want the contents inside the list object, you have to use double square bracket. Okay? You can only put you are not allowed to put in. So here, let's make a list. Okay, list. I'm going to do 1 through 5, and then letters 1 through 9, and then 6 through 3. Okay, so here L, I've got a list of 3 things here. Okay, I can say I want the second and third elements in list using single square brackets. Okay, I can say this, and this will return back a list. So we can think of this as a train of 3 cars, and now it will just return back the second and third train cars. It's still a list. Okay, or I could say, you know what, just give me the second thing. That's fine. If I want the vector, so if I take this and I say, give me back the 5th thing here, it's going to say that doesn't exist because you're looking at this single object, which is a train, and inside is the letters A through I, and you're saying, give me back the 5th thing of this single thing. It says I can't do that, right? If you want the 5th letter, you got to say, I want you to go into that second vehicle, okay? And then you get the vector, and then you say, I want the 5th element there, and it will say, that's the letter E, okay? When you use the double square brackets, though, because you're saying go into the vehicle, go into the train car, you cannot give it multiple elements. You cannot say, I want you to go inside the second and third train car. It's going to say, oh, okay. Of course, it doesn't kick back an error. What it's doing here is it's saying, I'm going to go into, it's seeing this as go into the second thing and then look at the third thing, because it's, that's what it's doing here. But, you know, if you said, it does a recursive indexing here. So when I say L2:3, it's saying, it treats this as look inside the second train car and then the third object in there. And so it gives you back the letter C. But, you know, if you did like 2 through 4, it's going to say, this doesn't work. Okay. Is this okay? This, so the important thing is single square brackets on a list return a list. Okay, I think this is what we said. Data frames you can use, so because data frames are lists, you can also use the double square bracket to extract one of the columns. How did I have 65 pages here? Okay. We're going to run out of time. Simplifying versus preserving. Okay, so we talked about this when you subset a matrix. It's going to, and you ask for a single row, it's going to simplify that to a vector. Okay. If you want to preserve the structure, include drop equals false. All right. And then this is kind of, a lot of things will simplify, or if you want to preserve the thing, right? So if you want to simplify a data frame or, you know, a matrix, if you say this, it will simplify it down to a vector. And if you include drop equals false, then it will preserve that it is a matrix here. It's not as big of a deal for vectors and lists. Again, double bracket pulls out what's inside. Single bracket will always return a list. Okay, and then as far as vectors, it's not that important. It gets rid of names when you use the double brackets on the things. Okay, I think we've talked about this. Subset a list with single bracket preserves a list. Double bracket, it simplifies it. It pulls out what's inside. With factors, it gets rid of unused levels if you say drop equals true, but who's going to remember that? All right, with matrices, this is probably one where it does make a difference, and you might use this. So here I've got a 2 by 2 matrix. Drop, if I say I want the first row, and I include, so first row, all the columns, and then you give it a third comma, and you say, or another argument after the comma, you say drop equals false, it preserves it as a matrix, 1 row, 2 columns. The normal way, if you don't include drop equals false, it just simplifies it and returns a vector with the values 1 and 3. With data frames, if you use the single bracket, it returns a data frame. Double bracket, it simplifies it to just those values in a vector. Okay, and then whereas kind of data frame does kind of a little bit of funny stuff in that if you call out just a single column, it normally will simplify it, and if you want to preserve it as a data frame, then you include drop equals false. So it's 2 slightly different operations here. One is that if you have it behave like a list, it's going to behave like a list. And over here, when you have it act like a matrix, it goes that way. Hang on, guys. The $sign is a shorthand operator. So if you want to do double bracket, okay, you can say I want X $y is saying X double bracket y, okay? And but then if you want to like build a loop where you're going to go through different variable names, you can't say I want to subset empty cars based on the variable name, but you can use the double bracket here and it will search for the string where var is equal to cylinder, and then it will pull out the column named cylinder here. Okay, and then this does partial matching. Okay, I guess we'll continue on with the out-of-bound indices on Friday here.